Hello everybody, welcome to my channel again. Today I am going to discuss about a very interesting series of number which is called Fibonacci series. Now this series is different from the other series AP series or GP series which we discussed earlier. Here but it's a very interesting series because there are some interesting properties, and often nature follows some of the properties of this series. So we'll discuss in detail in this video, and I'll post another video next to it about some of the properties, how nature follows it. So let's proceed. So who discovered this Fibonacci series? In Europe, actually, there was a person called Leonardo Pisano Fibonacci who actually discovered this series. But we find that in old Indian literature, there are mentions about this series. And the series, how does it look like? It looks like 1, 1, 2, 3, 5, 8, 13. Means, what is this? So let us decode it. So in this series, the nth term is the sum of first earlier two terms. So third term is the sum of first and second term. So 1 plus 1 equal to 2. Then fourth term is the sum of second and third term. So 1 plus 2 equal to 3, like that. So it becomes like 1 plus 1 equal to 2, 2 plus 1 plus 2 equal to 3, then 2 plus 3 equal to 5, 3 plus 8 equal to 8, uh, and 5 plus 8 equal to 13, like that the series goes on. Now we'll discuss some of the interesting properties of the series. Now, in this series, if we see, this is the first property that I want to discuss. So in this series, if we see, if there are three consecutive number a, b and c, then we will say b square minus a into c equal to plus minus 1. What does that mean? It means that if there we take any three consecutive number in this series, the middle term square minus the first term into the last term equal to plus minus 1. So, so if we see, so for the first three terms, 1, 1, 2, it is 1 square minus 1 into 2 equal to minus 1. Similarly, for 1, 2, 3, it will come out as 2 square minus 3 into 1 equal to 1, like that. And it goes on like that. So next property of the series is, if we take four consecutive numbers in the series, then it looks like a into d minus b into c equal to plus minus 1. So if a, b, c and d are the four consecutive numbers, so it's like 1, 2, 1, 1, 2, 3 are the four consecutive numbers of the series, first four consecutive numbers of the series. So it is like 1 into 3 minus 1 into 2 equal to 1. So so 1 into 3 minus 1 into 2 equal to 1. Similarly, 1, 2, 3, 5, if there are so five consecutive or three consecutive four consecutive numbers of the series, next four consecutive numbers of the series, then it is like 1 into 5 minus 2 into 3 equal to minus 1, and it goes on like that. Let's go to the next property. Okay, so this is an interesting property of the series, which is like, if we sum any two terms, consecutive term, n terms of the series, if we sum of the n terms of the series, consecutive terms of the series, then it the sum equal to n plus 2th term minus 1. So what does it mean? So first two terms, if we sum up, 1 plus 1 equal to 2. So the first two terms is 1 plus 1 equal to 2. So how many terms we have summed up? Two terms. So n plus 2, 2 plus 2 equal to 4. Fourth term is 3. So 3 minus 1 equal to 2. So 1 plus 1 equal to 2, 3 minus 1 equal to 2. So this is what the property test. Similarly, the if I sum the first three terms, 1 plus 1 plus 2 equal to 1 plus 1 plus 1, 2 equal to 5 equal to 4, right? Similarly, there are three terms. So three terms means 3 plus 2 equal to fifth term. So in this series, 1, 2, 3, 4, 5, fifth term is 5, right? So 5 minus 1 equal to 4. So left side equal to right side. Similar, like that, if we go on like that, if we'll go we'll find the summation like that, we'll find that the property is valid, and it's a very interesting property to find the sum of the first n numbers of the Fibonacci series. Interesting fact about the Fibonacci series 4, that it is the fourth interesting property that I found it's quite interesting. In this series, if the sum of the n odd terms of the series is equal to 2 into nth term of the series. So what does it mean? So first two odd terms, that is one odd term is 1, first is 1, and then second, third is another odd, so 1 plus 2 equal to 3. So so there are two terms we have summed up, two in odd terms. So there are two odd terms we have summed up, so we have to see fourth term of the series, 1, 2, 3, 4. So fourth term of the series is 3. So so it should be equal to 3, and we find it is equal to 3. Similarly, 1 plus 2 plus 5, that is 8. And three numbers we have summed up. So sixth term, 1, 2, 3, 4, 5, 6. Sixth term is 8, so it is equal to 8. Similarly, the first four terms, four odd terms, if we take, then it is 1 plus 2 plus 5 plus 13 equal to 21, which is the eighth term of the series. We go to the next property. Now, this is a very, very interesting property of the series, and it has many applications in nature. And let's see what is the property. The property says that first one square, where I the series is 1 plus 1, 1, 2, 3, 5, 8, like this. So if we sum the squares of the first two terms, that is 1 square plus 1 square equal to 2, right? So what is 2? 2 is 1 into 2, that is second term into third term. Similarly, if we sum the squares of the three terms, 1 square plus 1 square plus 2 square equal to 6, it becomes mm, uh, it becomes the third term, that is third term of the series, 2 into 3, fourth term. Similarly, if we take four terms, 1 square plus 1 square plus 2 square plus 3 square equal to 15. So we have summed up four numbers of the series. It becomes equal to fourth term into fifth term. So what does it mathematically mean? How does we represent it? If we see this diagram, so one square, if we see the middle square, one square and one square. If we sum these one or plus one, what we two squares we sum up of one a square of one unit length each. So two squares, if we sum up, then we see one side we get two length, and another side we get one length. So it becomes 2 into 1. So that is what we have written. 1 square plus 1 square equal to 2 equal to 1 into 2. So, so now if we give the second, if we add another square which is 2 square to this one, then one side of the diagram becomes a length of 3 and another side becomes 2. So this is 3 into 2, that is 6. So the area of the rectangle becomes 6, and that is what mathematically is coming out, that 1 square plus 1 square plus 2 square equal to 6. Now if we add a square of 3 to it, as you see in the diagram, 1 square 1 square 2 square plus 3 square, what we get is one side is 5 and another side is 3. So 5 into 3 equal to 15, and it goes on like this. So it's a very interesting property, and we'll discuss more in the next video how why it is interesting and how we find its application in the nature. But let us recognize that this series has this very interesting property that square of the terms, n terms, is equal to nth term into n plus 1th term. Now, this mm, the sixth interesting property of this series is that the Fibonacci series, uh, the ratio of two consecutive terms tends to a golden ratio as we go towards infinity, as the series goes towards infinity. What does that mean? So n plus 1th term by n term tends to be equal to golden ratio as the n increases to infinity. So in this um, chart, you see that this left side, the first column is the series 1 plus 1, 1, 2, 3, 5, 8, 13, 21, and goes on. That is the Fibonacci series, and on the right side you find we find that the ratio of the number to the previous number. So second row we find 1. What is 1? 1 plus divided by 1. Third row we divide by find 2. What is 2? 2 divided by 1. Fourth row we divide 3. 3, what is 3? 3 divided by 2. Similarly, if we go to the fifth row, we get 5, or 5 divided by 3, that is 1.667. Like that, if we to go on, in the last we get go see that the ratio tends to be equal to 1.61803. So now this ratio is called golden ratio. Now this ratio have some properties, and it's being replicated in many ways in the nature. So it's a very interesting ratio. We'll discuss this in the next video. But this video is mainly for the properties of the series. So we conclude the video here. Uh, these are, I found personally found these are the very interesting properties of Fibonacci series. So I wanted to share these with you all. So uh, again, I would request all of you to subscribe to my channel. It will help me to post more videos which are very interesting, which demonstrate very interesting properties in mathematics and science. So I would request all of you to subscribe to my channel, and thank you. I will see you again in my next video.